It's a pleasure to have you here, and please join me in welcoming Elaina to the stage.
Testing. You guys can all hear me? All right. Well, thank you for the wonderful introduction. I did actually do a talk about data science and astrophysics last time I was here, so it might still be on YouTube. But today I want to tell you about a little bit something different, a different way of thinking about data science. And some of you might be quite familiar with this, but what I wanted to do today is to kind of give you guys a little bit of my thinking on data science and machine learning and how the process of data science and the process of machine learning actually work, and a little bit about what they mean, and of course some context and some helpful tips as well, because everyone likes some helpful tips. So thank you very much for having me. I'm Dr. Elaina Hyde, and like I said, I'm a consultant at Servian, and I'm an adjunct fellow at Western Sydney University. So I kind of have a little bit of a technical background anyways, but before we get started too far, all of my public talks, I always like to remember to do an acknowledgement of country, because it's always nice for here in Australia to pay respect to the traditional custodians of the land. Here in Sydney, that will be the Gadigal of the Eora Nation, and I just want to take a second to pay respect to the elders past and present, and it's upon their ancestral lands that this building stands. So, what is data science? This is something that a lot of people ask in forums. What is it? What does it do? Is it Python? Is it a programming language? What about Pokemon Go? Is that data science? Is that what data science is used for? How about talking cars? So self-driving, fully talking, amazing cars. Is that data science? The Matrix. So I'm hoping that it's not so old that there's too many people who haven't seen it yet. But if you haven't seen it, you should definitely watch the first Matrix movie, because there's going to be a lot of things that I'm going to refer back to in these slides. One of the best things is, never send a human to do a machine's job. So data science, what is it? Is it any of these things? Is it all of these things? And what the answer is, I'm going to try to illustrate with examples a little bit today. So how can we understand data science? If we're trying to figure out what it is, maybe we can understand it in terms of its environment. So in terms of the tools that we're using, the processes that we're using, maybe the end goals that we might be using it for. So data science has a lot of things that we can do within data science. And it can be used for a lot of other things. But if you view it as a process inside of a process, what you actually see is that machine learning, your EDA, your statistics, a lot of things are actually enveloped inside data science. And once you have all of those processes mapped out, you can find out how your data science can apply to consulting, or economics, or research, or business, or marketing, whatever you're interested in. But you have to kind of get an idea of how these things work. So what might be a simple process? I thought to myself, maybe there's a simple process that I could go through that would kind of try to illustrate a few of these points. So a lot of us are familiar with the idea of gathering up data. We might want to do something with that data. We gather it up and we clean it and we make it look nice. So that's what's happening up in the top two up there. We gather some sort of data together. We make it into something like rows and columns. Maybe it's a report for our company. Maybe it's all the different kinds of cats in the world, right? Could be ranking of every character in the first Matrix movie. Anything you like. We're gathering it together. We're making it clean. We're structuring it into some sort of columns and rows. And once we have that, we can then look at what's called the EDA, the exploratory data analysis. Now this is actually, small spoiler alert, its own process. But what we do there is a lot of statistics. We look at histograms and bar charts. We try to characterize what's going on. And we then sort of do that analysis. We find out that the best character in the first Matrix movie was actually that glitching cat, or we find out that the best point for us to sell our products is December because we get the Christmas peak. And once we have this information, that's when you start looking at machine learning, right? So then we start thinking, how can we group our data? How can we generalize our data? What can we do with it? What kind of models and algorithms are we interested in? So it kind of goes naturally to that next step. And from there, we can look at things like visualization techniques and creating data products that might be used and making good decisions. That last one's a dashboard, which is a really popular thing for a lot of people to use. So wouldn't it be nice if this was true? So actually, this is the real state. The previous one was far too nice, right? So that was much too streamlined. What we have actually is a lot more going on. So we might gather our data like we did before, but actually gathering our data has got its own process. The extract, transform, load, ETL. Has anybody heard of the ETL process? Yes, okay, good. So you'll need that a lot. Raw data collection. So if you've got that process down, you've only actually got that first part. And that ETL is going to be informed by what your data looks like later on when you create data products or what kind of data products you need. And so you see all those black arrows, those are all of this crosstalk that happens. And you actually go back and forth. It's not, unfortunately not nice and linear. It's more cyclical, it's more iterative, it talks to itself and it has to inform itself what's going on. And that's going to be something that's going to come up again and again when we're looking at this. So every process that we've got has a link and another piece that it can talk to. We've got, like I said, dashboards, trained models we might want to deploy. Our visualization might actually give us feedback to what we needed to do really in our EDA. And once we have our decisions, we might choose to do even more things later on. So it's actually a complicated environment, but unfortunately, fortunately, there's even more. So if you guys thought that was data science, I have to tell you about another part of data science that's also included. Because when you talk about how to make these nice things, put your data together, and create machine learning models, you also have to think about the people involved. And when you talk about data science, some people will actually be really talking about business solutions. They'll be talking about workshopping. They'll be talking about defining problems. They'll be talking about creating personas and tracing data flow in an organization. They'll actually be talking about this very, very different but necessary part of data science. And so you have to keep in mind that there's also, in addition to data that goes all over and has its own processes, there's people interactions that will have their own processes as well. And that's just a few of them. So why is this so complicated, right? Why can't I just tell you what data science is in one definition like the dictionary probably has and I should have included. But that would defeat the purpose of this talk, because I'm trying to show you what it encompasses or what it can encompass. And some people will say data science and they will mean one of the things that I'm talking about. And some people will say data science and they will mean all of the things I'm talking about. And that's really just important to know when you're having any conversations with prospective employers or colleagues, which ones they're talking about. So data science has processes. It's full of processes and it's itself a process. So if you think of it as processes full of processes, I hope this graphic helps. I made it myself last night. So if you think about how they work together, how you might work with consulting to figure out what kind of statistics would be useful for their business, how you might work with databases to determine what the best kind of results would be, and how that can work all together as part of a big machine. Now, some people, like I said, they'll only be talking about maybe machine learning. That's actually a very common thing, at least for me. I've heard a lot of people say data science, and they really mean like pretty much machine learning or training and deploying a machine learning algorithm. So just be careful with which one you're talking about. So one thing that helped me a lot because I do come from a technical background, was to think about it scientifically. So I'm not going to assume anyone else has done any astronomy, but if you've done any kind of science or you've heard about science, you know that there's something called the scientific method. And the scientific method is really popular with a lot of us who've been through it, because it gives you a method to solve problems. It's a general process that you can follow. It's iterative, it's cyclical, so it's a method of trying to get some kind of advance in your own knowledge. And what you do is you use characterizations, hypotheses, predictions, experiments. So what about data science? And I thought, well, this is a nice parallel, because for me, what I'm doing is I'm using characterizations, hypotheses, predictions, and experiments or tests of data, right? So I'm not just using these, it's of data. So it has to be from data, otherwise it wouldn't be data science, right? So if you look at that and say, look, I can use this kind of a process, but in data science you also have a larger view. You have that consulting with people view. You have the system that you're working with. You have results and an analysis from earlier steps. And instead of, so there's some differences as well as some similarities. And one of the nice things in the scientific method is I can actually make you a list, 1 through 8, of these are the steps you should do. And it's nice and it's linear. And if you do these steps, you've got your method to get some sort of result, some sort of information about your question. And it's a very nice little scheme, and it will be really useful for data science as well. But on the left-hand side, the data science side, we're doing that steps 1 through 8, the defining a question, gathering information, making a hypothesis, we're doing all of that, but we're doing it many, many, many times. It's lather, rinse, repeat. And we're doing it under the data science sort of ecosystem, the data science process. So we're also doing consulting, we're defining our question up there. Our ETL will actually have our information gathering part of it. The EDA, that will have the analysis part. And the data science, so this is the data science inside data science, not to be confused with data science, right? So, anyone follow that? No? Okay, one person. All right, so.
For a resolution problem.
So data science as creating the hypothesis, doing the modeling, retesting, and then maybe working with the EDA and having that level. So if you're just doing that part of it, that can also be your data science. So what I wanted to make sure that everybody had was this idea that there's a lot more going on. So that's my definition of data science. Processes inside of processes. And you'll find that for every definition of data science, there's somebody who will say, oh, actually, I've got my own definition. And so it's good to remember that this is a little bit subjective. So people will have their own working definitions, and organizations will have their own preferred types of, say, look, I'm going to split up and have my analytics department here and my data science department there, and they're going to do very different things. So just keep in mind that everybody's kind of got that, umbrella of definitions that they work under. So one of the ways I thought would be nice to illustrate this was to talk about one of the processes within the process. So machine learning is under the umbrella of data science. It's a type of artificial intelligence. So machine learning, what is it? It's also a process. And obviously, I'm supposed to stop at 25 minutes, I've been told. So we're not going to cover all the processes. But I can kind of try to give you an idea about how does the machine learning process work under the data science process, and what are the similarities there, right? So I said that data science has all of these other processes in, and machine learning will use some of the things we've talked about, and it's going to have its own iterative, cyclical process. This is where I recommend everybody watch The Matrix again, because it's got all of this in. And you really do have to see the machine learning for yourself to be able to understand it. So I've tried to get some little demos here. We'll see how much time we actually have. But this is what I like to call probably the fastest machine learning you'll ever do. There's a few things like this out there, but they're pre-trained models that you can then use yourself. So this is an example from the Google Arts and Culture app, which I have on my phone, and this is where I always ask for if anybody wants to try it. So the Google Arts and Culture app, I always thought was a really cool example because it's an app about museums. It's got paintings. It's got different types of museum things, statues. And they had this whole app all about it, and people were using it a little bit. But they found a way to do a huge value add by implementing a machine learning algorithm that would take a person's picture and match them to a famous thing, a famous painting. So here I am. I said, look, I'm a person with the headphone or a headband. Definitely, I'm that person. Look, I'm a famous painting, and I can put it on Twitter, and I can tell everybody I got it from this app. And it raised a huge amount of awareness about their app. It raised a huge amount of attention, and it really increased their users. I still have it on my phone, and it's a really, really quick and fast one. So usually I do this talk in much smaller groups. But is there anybody who would like to see if they're a famous person? Volunteer. So just take your picture.
But first, let me take a selfie.
Yeah. So obviously, if you have a lot of time, you just do this until you got a really, really good one and match somebody super famous. So you've got the result here. Okay. So wait, let's anonymous. Let me see if I've got any matches to, third Earl Cowper. Okay, good. So this worked. So we do have a possible Earl in the audience, right? So yes, I don't actually know where Cowper is, but if you go there, you would have a good match. So obviously, you guys can all do this. I checked; it's available for iPhone and Android. If you feel like getting it, it's very, very fun, highly recommended, and it took less than 1 second to get this match, right? And likewise, my match as well. So you'll notice that there's also that really old guy in the picture that I'm not clicking on because you can pick which ones you want, and then pick the best match. So why does this work? Why is it working when I click my picture and it tries to match me against the paintings? Obviously it's a trained machine learning algorithm, but why is it working, right? So how is that knowledge happening? Not like humans learn, right? So probably you guys have heard this before, but it's really important and worth remembering that machines do not learn like people learn. Machines learn from data. They only learn from the data that you give them. And so if you don't have a very good picture database, you're not going to have great matches to people when they put their face up and try to find a cool picture of themselves. And that when they first came out with the app, they actually had to go back and retrain it because their museums that they were using didn't have a good enough picture database. So machine learning used the data that it can have, the data that it has access to, and it generalizes. It tries to make some general assumptions about what's happening, but it does it as a machine would. Now the routine you guys just saw was really well trained, and it might have had some existing categories that it was putting people into. Now we're not going to have time to do this. We're definitely not going to have time to do this one. But I'd like to recommend a machine learning tool for anybody who is just getting started. It's called the Teachable Machine. It's https://teachablemachine with google.com. And if you go to that site, it'll give you a tutorial on how to train a machine learning algorithm. And what you do is you use your video camera on your computer or your phone or whatever, and you do a motion. So if I pick hand waving as a motion, I only wave my hand, I don't do anything else, and I hold down the button for train green category. And the machine will, hopefully, if I do it well, I have the data, enough data points, and they're convincing, I'm not getting photobombed by my cat or whatever, then eventually the machine will know that if I'm waving my hand, it's in the green category. And you pick a thing to do for each category, and then once it's trained, in your live video feed, whenever you're doing that thing, the category is triggered. And in this case, what they've said is, green category means show a cute kitty cat that's waving its paws. So it's really cute. And if you train your machine well, and you create enough data that's labeled and in a good format, you'll be able to have your video response showing you either a cute kitty, a cute puppy, or a bunny rabbit. I suppose the bunny rabbit's cute as well. And it does work, but if you don't have enough points, it will definitely fizzle out. So the main points here are your data is key, and it's generalizing from the data that you give it. Now it can only use the data that it has, and how it's going to do that is by running it through some sort of process. So you saw before the kind of the data science process that I had. Ideally, we'd have some data, it would go from one place to the next. So this is the machine learning process within the data science process. And it has a lot of the same components. It comes from some sort of data sources. Maybe you have a nice database, maybe SQL, goes through some preparation, and into some sort of machine learning area where then you say how good is it done, and then depending on how good it is, you might go back and start over. So that's the general overview of how the process might work, but in practice it looks a little bit more like this. So this is again, this was my experience with the reality of machine learning, which is things all over the place. You have some sort of process up here for your data, when you're doing your exploratory data analysis and your modeling, but then you've got a lot of other things you're doing. You're having validation, you're doing cross-site validation, you're scoring, you have extra parameters outputting here, you've got feedback of those results all the way back up into your data cleaning sometimes. You find out that you actually had to do some totally different format thing, and it takes a while. It takes a lot of time to learn the ecosystem, but as long as you remember that it is iterative and it's only as good as the data you give it, you won't have happen to you what happened to these guys. So this is a nice little case study. It's from a paper called Why Should I Trust You? Which I believe is the authors talking to their machine learning algorithm and not necessarily to me personally. It's a nice little paper. Anybody can grab it, but it's basically a bunch of people who wanted to find out how to identify dogs in images. And so they had lots and lots and lots of dog images. They trained and trained and trained. They checked all their scores. It looked amazing. And then when they went to use their machine learning algorithm, they found out that all of the husky dogs were classified as wolves. And that's not good. That's not what they wanted. But their accuracy and all the scores were so amazing. Why? And one of the nice things in an image algorithm is you can actually get it to return the significant parts of the image that it's using in the algorithm, and they did that. And that's the part on the, let's see, your right-hand side. So that's the mostly gray image, and you'll notice there's no dog, right? So what the machine was using to identify whether or not it was a wolf was only the snow. And that's because all the images that it had in its database were wolves in snow. And so when you went through all the images and said, oh, what's the unique feature here? It picked out the thing that was common. And so you have to watch out for that in your data. Now, machines don't think like humans, right? They never have, they probably never will, really. There's actually a great extra conversation you can get onto with Descartes, but we won't go there today. So machines don't think like humans, and they, Agent Smith from The Matrix has told us, never send a human to do a machine's job, But my main message for you guys here today is please do not send a machine to do a human's job. Because if it's a human's job, it's going to require a little bit different type of thinking. So we could test this. I don't think we quite have time, but if there's, how many minutes? 5? 3? Okay. If somebody asks me how the decision tree works, we'll be able to do the example pretty quickly. I think it'll take about three minutes, but we'll put it into question time for now. So one of the best examples of machines not quite thinking like humans comes from the decision tree, which is an algorithm that does classification and regression. And it uses a strictly if-then that sort of logic, very strict sort of logical structure, and it branches out and forms those categories within that structure. So we'll skip on testing that until we're in question time. So finally, what I'm going to do is I will have all of these links up on the meetup.com meetup for today. I'll put them in the comment section. But I do want to give you guys some tools, right? Because tools are really, really useful. And these are some of the most useful ones that I've seen. Mostly, because they keep coming up again and again. But Python 3 and a really good package manager can get you super far. Once you've got that, I actually highly recommend Topcat. It is an astronomical software, but it's really, really good for your basic EDA. Very easy way to get a good look at your data. Obviously, GitHub is huge. I have a GitHub blog that's got a lot of this information on it as well. Twitter's not really on there, but I forgot to say you can find me at Hyde and ask me questions later if you want. Jupyter Notebook's really good, and of course the option, any kind of extra reading you can do on Python pandas packages is going to help you a lot. So a lot of tools that we have. This again is kind of the main tools that I see keep coming up again and again. Spark and Hadoop underpin so much of what's going on today, even in cloud computing on GCP and AWS and other cloud platforms. PyTorch, really, really nice. OpenCV, if you're thinking about doing some machine learning on the fly. And SQL, still super handy. People keep telling me SQL is outdated, but I see it all over the place. So just a quick little non-comprehensive list of my favorite tools. And again, I'll put this up in the comments. So I'm not expecting everybody to immediately write all these down or anything. So you'll be able to find it in the comments for the GCP the comments under meetup.com DSS Sydney area. So this is just some links I wish I'd had earlier. The Python Data Science Handbook is probably my favorite. And there's also some really nice how-to guides for how to get started in Python or how to get started with machine learning and statistics. So if you haven't had a lot of statistics before and you're thinking about getting into the more technical part, I always start with statistics because they're going to help you so much with your EDA. So finally, what is data science, right? I asked the question at the beginning and I'm asking it again at the end. It's a process full of processes. It is about the tools because the tools are very important. We couldn't do what we do without them. But it's also about the logical process that we use, that iterative, cyclical verification process. And it does bear some resemblance to what some of you might have heard from things like the scientific method, but it's actually a lot more than that. It's a process of processes that can lead to a lot of really interesting results in marketing and economics, in consulting, in business and research. And that's where I'm going to leave you guys for today. So thank you very much.
Thank you.
So do we have five minutes of question time?
Of course, we have 5 minutes of questions.
Okay, can we have exactly 5 volunteers lined up somewhere?
Yeah. Okay.
Constraints over.
Okay.
This is going to be a very interesting question time.
One question first?
I get a question. So how is it that machines think differently from humans? And if possible, can you give your answer with the example of a decision tree?
Yes, thank you. All right, so I just need some volunteers. who can ask a question quickly. And if you just come stand next to somebody with a microphone. Do we have
Okay, good. I have 5 people standing in the queue right next to me.
I'll pick people.
What do those questions have to be? Are you telling them?
I'll tell you what you have to ask, but we just need the people to line up really quick.
Right. Thank you. Thank you. Thank you.
1, 2, 3. Okay,
Cool.
3.
2. One more spot.
All right.
Okay, come.
With the X factor.
Okay. All right. So machines don't think like humans. The decision tree works as an if this then that type of classifier. What can also work as an if then that classifier is a game called 20 questions. So today you guys are going to be a machine learning model, and we're going to show how this thought process happens. And has anyone not played 20 questions? Okay, so yes, this is awesome. Good planning. So all you have to do is ask me a question, and I will only answer by yes or no. And you have to find out what the answer is, because you guys are the decision tree. So I'm going to ask you guys, what is my favorite movie? And you're going to find the answer to this question by asking me a yes or no question, and sort of quickly as you can, and see if you can. And anybody who guesses it anywheres will immediately stop, and we'll.
Can I guess now?
I
think I already know.
I kind of want to guess now.
I want to guess now, but we'll play the game.
Yes or no question? Go.
We'll play the game.
Is this movie a science fiction movie?
Yes.
Is the movie Matrix?
No. That would have been too easy.
Is it Inception?
No.
Did the movie come out in the last 3 years?
Ooh, that's a hard question. Make it last. Definitely within the last 5. But I'm not that good at my sense of time. So I'll if you make it 5, then I'll say yes.
Is the movie a sequel?
Is the movie a sequel, or does it have a sequel?
I'll take both.
Is the movie a sequel? No. Does it have a sequel? Yes. Okay, you have to ask a question. Ask a question.
Is the movie by Universal Pictures?
You guys are asking. Okay, no, I don't think so.
Is the movie set on the planet Earth?
No. Well, like the first 5 minutes.
Majorly set on the planet Earth.
Does the movie is the director Steve Cameron?
No.
James Cameron?
James
Cameron. James Cameron.
Still no.
Is the director George Lucas?
No. So all you know so far is it's science fiction. The audience is helping. This decision tree is growing larger and larger.
Is it Divergent?
No.
The decision tree or the movie? Take it either way. Anaphoric resolution.
Is the lead character a male or a female?
That's not answering my question.
Is the lead character a male?
Dummy
Yes.
variables, mate.
So it's a science fiction movie in the last 5 years, I'm pretty sure, given my sense of time. And maybe I should check that.
It's a long time since Avatar.
Is it Guardians of the Galaxy?
Yes!
Bingo! Bingo!
All right, so our decision tree worked by 1 block at a time, right? So normally we don't have conversations like this with our people we know. We don't only respond in yes or no questions. So thank you to all the wonderful volunteers. Because it would take a really, really long time. It's not efficient. It's a fun game for humans to play, but humans aren't particularly good at this game. What is good are machines. And so that's the difference, right? Machines can be very, very good at this kind of game. Not good at the game that, like what I'm doing right now, which is trying to talk to you in a conversational manner, but good in this kind of a game, which is why when we tell time, we use machines, right? If I had told the best person in the entire world to please keep track of time right now, and they had to sit there and count the seconds, right? At some point, they're not going to be very accurate. Probably within at least a couple hours or so. They're really, really, really good. They're not going to be as accurate as using a clock, right? And so machines are really, really wonderful at keeping track of time. They've now gotten to the point where there's atomic clocks, and they're super, super accurate. It's amazing. But you wouldn't want to confuse that with what a human can do. So that's my final little demo. Thank you very much for your question. Back.
Any other questions though? Didn't. Are we letting you off the hook just yet?
If we have time for another question, I'm happy to take it.
Anyone? On that end? Well, in that case,
So everyone knows what data science is now.
mystery solved. It's that easy.
right.
Thank you so much. Thank you so much. Changeover. Please feel free to grab some slices of pizza. There's still some left in the corner, or in the other corner.